This video is first one of series devoted to WebUI Test Automation. Preliminary plan of the whole course is on the screen. The plan, however, may change slightly as we go. In today's video we do introduction to WebUI testing, key benefits and types of it. And so in this one there is more talking than practical skills learning. The talking is needed, as it is important to establish key elements, reason and priorities. But don't worry, there will be some learning as we take a sneak peek into Chapter 2 of our course. As we all know, user interfaces are gateways through which users interact with our applications. A smooth, intuitive, error-free experience can mean the difference between satisfied user and one who lives in frustration. That is why WebUI testing is so critical. Functional WebUI testing is all about ensuring that elements users interact with, buttons, forms, navigation bars, all the visual components, work as intended. When we talk about importance of WebUI testing, we are talking about ability to confidently say that our users will be able to access all the features easily, complete tasks without obstacles, and hopefully enjoy consistent experience regardless of the device or browser they use. One of key benefits of WebUI testing is that it helps catch issues early in the development phase. Imagine a scenario where a critical button on our website doesn't work. The frustration for the end user is immense, but the financial and reputational cost to the organization could be even greater. Automated WebUI tests help us quickly detect such issues before they make their way into production, where they can impact end users. Part of WebUI testing also to ensure cross-browser compatibility. Users access applications from a multitude of browsers and devices. Something that works perfectly in Chrome may behave differently in Firefox or Safari. By doing WebUI testing, particularly with cross-browser capabilities, we can ensure that our applications are consistent across all the platforms. This enhances overall confidence of quality and reach of our product, making sure that we don't leave any users behind. Another major benefit is regression testing. Web applications evolve quickly, new features are added, existing ones are modified, and sometimes entire sections are redesigned. This rapid pace can lead to unintended consequences, where new changes break existing functionality. Automated WebUI testing helps us perform regression testing quickly and efficiently, making sure that the application continues to work smoothly even after updates, saving time and reducing risks of unexpected issues. Moreover, WebUI testing contributes to cost reduction in the long run. Although automated tests require an initial investment of the time and resources, the ability to reuse those tests every time a change made saves significant effort in the long term. By reducing manual testing needs, we can free up valuable human testers to focus on exploratory, high-level testing rather than repetitive tasks. Now that we established importance and benefits of automated testing, especially when application under test does evolve quickly, it is right time to mention that in order to provide above-mentioned benefits, it is important to design test automation with certain principles in mind, to withstand those rapid changes without need to recreate automated tests, require minimal maintenance to provide as quick feedback as possible. Such kind of automation I call sustainable. More about it in the following series. For now, I want to highlight a key point. Sustainable test automation must be carefully planned and implemented. Simply having test automation in a project is not enough to guarantee promised benefits. However, when it comes to WebUI projects, the importance of good test automation architecture is even greater. A poorly designed test suite can quickly lead to maintenance nightmare, undermining all the advantages that test automation is meant to deliver. On a very high level, WebUI testing split on two areas, functional and non-functional. Functional testing validates that web application works as expected by testing its features and user interactions, such as button clicks, form submissions, and navigation against defined requirements. The things we mentioned already earlier. Non-functional testing evaluates aspects like performance, usability, scalability, security, compatibility to ensure the application meets quality standards beyond its core functionality. In this series we will not cover non-functional testing, as it is a different world full of different activities and tools. Before diving into functional WebUI testing, it is essential to understand basic building blocks of web page, HTML and CSS, and how we leverage them to locate elements in the tests. We'll also discuss different strategies for identifying elements reliably, using IDs, CSS selectors, and XPath. By understanding these fundamentals, you can write more stable and maintainable automated tests. HTML is the foundational language that structures every web page. It's composed of elements represented by tags like HTML, head, body, and so on. These elements nest inside each other, forming a tree-like structure known as Document Object Model (DOM). As testers, we interact with this DOM to perform actions like clicking buttons, entering text, or checking displayed messages. Understanding the basic layout of HTML lets you navigate the DOM logically, making it easier to identify the elements you need to test. Web pages contain a variety of elements: div blocks for layout, input for text fields, button for clickable actions, table for tabular data, and others. Each element can have attributes like ID, class, and other ones. These attributes act like labels you can use to find the element. For instance, if a login field is an input with ID login name, you know exactly where to type in username. Attributes are the first keys to create robust test locators. Automated web test conceptually is a script or set of scripts simulating a human user interacting with web application. At its core, this involves verifying data and content. Once elements are identified, the script reads displayed information, like text on a button, values in a field, to confirm that the UI shows what expected. Performing user actions. The script imitates real user actions, clicking a button, scrolling down the page, typing text into the input field, to confirm that the web application responds correctly to typical user interactions. Other operations. Automated tests can also handle more complex scenarios, such as waiting for dynamic elements to load, switching between multiple browser windows or frames, and validating that certain conditions are met before proceeding. For test script to interact with HTML element, it needs to locate it. When locating elements, you typically have three main strategies: IDs, CSS, and XPath. If an element has unique ID attribute, this is often the most straightforward and reliable locator. For example, if a login button is a button with ID equals login, you can directly target it. IDs are fast and unambiguous if used consistently by developers. CSS selectors let you target elements based on their classes, attributes, or hierarchical relationships. Examples are on the screen. CSS is typically easy to read, maintain, and it performs efficiently. They are often the to-go method if IDs are not available or reliable. XPath is a powerful querying language, originally designed for XML, but it also works well with HTML. It provides even more advanced features than other two methods. A simple XPath selector is on the screen. More complex XPaths can navigate up and down the DOM tree, select elements based on their text, or find elements by their position. While XPath can be incredibly flexible and useful for dynamically generated pages or when no stable attributes are available, it can also become more complicated and harder to maintain than IDs or CSS selectors. It is a great tool to have in your toolkit, but one you should use judiciously. How do you decide which locator strategy to use? Start with IDs. If the development team provides unique and stable IDs, use them first. They are simple and less prone to breakage. Use CSS selectors if IDs aren't available. CSS is often used as the next best choice. They are readable and easy to maintain. XPath when necessary. XPath is powerful and can locate elements in very dynamic and complex DOMs, where IDs or CSS selectors fail. However, try to keep XPath simple to avoid fragile tests. By mixing these approaches, you ensure your tests are both resilient to changes and straightforward for future maintenance. So, let's summarize. HTML is your roadmap. Knowing how elements are structured helps you to navigate the DOM. Attributes are your anchors. IDs, classes, and names help you to latch onto elements consistently. CSS and XPath are your tools. Use CSS selectors for clarity and maintainability. Employ XPath for flexibility and complex scenarios. Armed with this understanding, you can build automated tests that are easier to write, more stable over time, and simpler to maintain, no matter how the application UI evolves. In WebUI testing, a little HTML and CSS knowledge, along with solid grasp of locator strategies, is all you need to efficiently and accurately interact with page elements. With these fundamentals in place, we are ready to move forward into writing our first automated test and applying these principles in practice. In the next episode, we will better understand basics of WebUI testing, explore how to set up your test environment, and run simple automated tests using the concepts we've just covered. Thank you for watching and see you in next episode.